Putting it in storage is the current recommended course of action for dealing with nuclear waste. This certainly has certain shortcomings. But what about the other options we have? The present method for dealing with the tens of thousands of tons of high-level radioactive waste produced by the world's nuclear reactors is simply to store the garbage. The explosion at the Mayak nuclear waste facility outside of Kyshtym, Russia in 1957 remains the third worst nuclear disaster in history after Chornobyl and Fukushima. This does not mean that there are no risks associated with this endeavor. However, the employment of rockets increased the risk of an inadvertent discharge of waste into the atmosphere if there was an explosion. This had led people to examine the potential of firing the garbage out into the solar system or into the sun numerous times while looking for alternatives. There have been some studies that have looked into the idea of utilizing high-powered lasers to shoot capsules into space. However, this option has been ruled out so far due to economic, dependability, and safety concerns, in addition to the likely presence of legal obstacles. Nuclear reactors are a good and reliable source of energy since they produce enormous amounts of energy with just a small quantity of material being used in the process. However, there are a few challenging issues associated with the use of nuclear energy. One of the most significant challenges is determining how to properly dispose of the radioactive waste that will invariably be generated by nuclear reactors. Although it is a terrific and dependable source of energy due to the fact that it generates an astonishing amount of energy with very little starting material, there are a few drawbacks and liabilities with the use of this method. This glowing junk, which is more accurately referred to as radioactive waste, is produced as the consequence of a variety of nuclear technology operations, such as nuclear power generation, nuclear medicine, and nuclear research, among others. Waste from nuclear power plants typically contains radioactive elements, making it an exceptionally hazardous substance. The presence of these radioactive materials is harmful to all kinds of life, including humans. The disposal of nuclear waste is one of the most significant difficulties that the modern world is currently facing. Modern human society has high aspirations of obtaining a significant amount of energy from the nuclear reaction process. A great number of individuals have formulated a variety of hypotheses and suggestions regarding the most efficient way to get rid of nuclear waste. One solution that is frequently proposed is to gather all nuclear waste and store it in containers with tight-fitting lids. The next step, according to this conception, is to make use of rockets to send these potentially hazardous canisters into orbit, where they can then be released, possibly towards the sun. Doesn't that just seem right? In point of fact, there are various problems with this approach. Propulsion is an upward force that can drive the rocket off the ground and to its planned destination, such as the International Space Station. This is an essential component of any space launch, regardless of the type of rocket that will be used. It is possible that a lot of people are unaware of the fact that the amount of propulsion needed to launch a rocket beyond the solar system is actually lower than the amount of propulsion needed when the destination is within the solar system, like sending the rocket to other planets or to the sun within the solar system. Why? Our globe rotates at a speed of approximately 460 meters per second, which is the equivalent of nearly 1,000 miles per hour at the equator. Therefore, the rotational velocity of our planet is added to the velocity of the rocket when it is launched off the surface of the Earth. In point of fact, this method is one that is utilized by space organizations all around the world in order to launch satellites and probes into orbit. After liftoff, the rocket will move into an inclined orbit, and then it will make use of the gravity of the Earth to travel to its subsequent destinations. In the fourth installment of the Superman film series titled The Quest for Peace, the Man of Steel gathers up all the nuclear weapons on the globe and launches them into the sun. The notion is a good one, and in fact, once every few years, someone suggests dumping all of our trash there. However, there is one issue with the plan, and that issue is the orbital mechanics. Because of the enormous amount of gravity of the sun, the amount of delta V requirements, also known as the amount of thrust that would be required to make it possible, is prohibitively high. The film makes the point that it is much simpler to escape the solar system than it is to send anything hurtling into the sun. In point of fact, the difficulty increases with the distance from the Earth to the sun. But if you want to send the rocket all the way to the sun, you're going to need a relatively large amount of propulsion for a few different reasons. First and foremost, you need to keep the rocket from flying away from the Earth's orbit. Second, you need to propel the rocket all the way to the sun. Even if enormous power is obtained, the rocket will still require more fuel as it gets closer to the sun in order to generate even more propulsion. This is because the gravity of the sun is significantly stronger. Therefore, the rocket will have a more difficult time reaching the sun the closer it gets to the star. In point of fact, the rocket has a greater chance of being trapped by the gravity of the sun, going into orbit, and then finally departing as if slingshotted away from the sun. There is an abundance of examples of unsuccessful rocket launches, and there have been many catastrophes caused by rocket launches throughout the history of space study and space exploration. Some of these incidents have even brought about tragic effects, resulting in the loss of lives. Each rocket, and the crew who operates it, will have an emergency plan in place both during and after the launch. When Ulysses was launched by NASA and ESA in 1990, it was the only space probe to ever travel close to the sun. They dispatched the probe to Jupiter in order to slingshot it into a few polar flybys of the sun, each of which was spread out by approximately 6 years in order to get it close to the sun. In order to get the correct orbit, the Solar Probe Plus, which was a NASA probe that flew very close to the surface of the sun, had to make repeated flybys of Venus. This allowed the probe's closest approach to the sun to be adjusted, which allowed it to get into the correct orbit. Now, let's say there was a problem with the launch of a rocket that was carrying high-risk radioactive trash. What would happen? It is possible to say that if the launch was unsuccessful, it will bring about disastrous implications for the entirety of the globe. The radioactive waste that was on the rocket is very likely going to be dispersed all over the place as a result of the action of the atmosphere. Then, there is the peril posed by debris in space. There are already a significant number of decommissioned older satellites orbiting space beyond our planet. All space missions face difficulties as a result of the fragments and debris left behind by these satellites, which are currently orbiting our planet. There is no doubt that the outcome may be even more terrifying if a rocket carrying nuclear waste fails to crash into the sun, but instead simply leaves the radioactive waste in space. This would add waste to the ever-increasing amount of space junk that is located in the ring of the Earth surrounding the planet. A space exploration project of this magnitude is almost certainly going to have very high costs associated with it. In point of fact, the expense is so great that no space organization will even bother to investigate whether nuclear waste from Earth should be sent into the sun or the moon, since they know it would be a waste of time. Launching all of the nuclear trash on Earth into space is not only an extremely hazardous endeavor, but it is also not economically possible. This is especially true now that we have other technologies that are more cost-effective for dealing with nuclear waste. In addition, we don't want to send radioactive waste to the moon because we don't want to contaminate the nearest celestial satellite with it. Even if we don't visit the moon very often right now, maybe one day in the future we will set up shop there and make it our permanent residence. That's it for today. Share your views about this by leaving a comment. And also, don't forget to press the like and subscribe buttons to enjoy more videos like this from our channel. Thanks so much for watching.